Hello guys, welcome to my channel. Today in this video, we will be proving a theorem which states that a subgroup H of G is normal if and only if x inverse is equal to H. We'll have to prove this in both the ways. Let's prove. Let H be a subgroup of G. We have been given xH at x inverse is equal to H. So here we'll have to prove H is a normal subgroup of G. That is, we have to prove xH x inverse belongs to is a subset of H, since it is a definition of normal subgroup. Here xH x inverse equal to H. So we can write it as is a subset of H, since we have learned in the earlier classes before, if A is equal to B, then we can write it as A is a subset of B and B is a subset of A. If A is a subset of B and B is a subset of A, then we can write A equal to B. We have used this property here. Now let's prove it conversely. In converse part, let H be a normal subgroup of G. Now since we have to prove xH x inverse equal to H. So to prove this, since H is a normal subgroup of G, and by the definition we have xH x inverse equal to is a subset of H. This is the first part. For the second part, let H belongs to H, G belongs to G. Let's take X. Since X is an element of G and G is a group, X inverse exists. Now we can write H as identity into H into identity, which can be formation, which we can make the formation of this as X inverse X inverse. Since it is of this format, it belongs to X H x inverse. Now we have to prove this part belongs to H. So for this, we can write it as x inverse H x inverse of inverse. Since we take inverse of x inverse, we will get x. So it will belong to H. Since this part is nothing but it will belong to x H x inverse. And since we know, since it is a normal subgroup, xH x inverse is a subset of H. So we can write it in this way. From this, we have proven, we have taken H from small h from the subgroup H, and we have shown that H is also contained in xH x days. So we have H is a subset of xH x inverse. So from 1 and 2, what we have brought there. Let's see. From 1 we have got xHx inverse is a subset of H, and from 2 we have got H is a subset of xHx inverse. So eventually we can write it as xHx inverse is equal to H, which is the required proof. Thank you.